Hey guys, welcome back to my channel once again. So in this video, we'll cover about the topic auxiliary engine control system, its alarms and trips as mentioned in ETO TAR book in Competence 1, task number 7. Alright, so this is engine control room that is present on my ship, and this is the auxiliary engine control panel. They mentioned it as a generator control panel. We can also call it as an auxiliary engine control panel. I'll tell you why. And in this generator control panel or auxiliary engine control panel, you're gonna find 4 generators, 2 shaft generator and 1 turbine generator. Because my ship is a high voltage ship, so we are having so much of power demand, and that's why we are having these much generators. All right. These are the meters, these are the indications that normally on a generator control panel. Okay. And this ammeter, generator control position comes for generator, whereas the governor control, the one which controls the speed, to start, stop the engine, basically it is controlling the engine. So yeah, that is why I told this is also like an engine control panel as well as the alternator control panel. The engine and the alternator are coupled together. The engine is driving the alternator. The mechanical force is converted into the electrical energy, the basic principle of alternator or generator that we know. So yeah, just to give you a refresh, Well, this is a synchronous scope, which is in the control panel. Yeah, this is also part of the auxiliary engine control system. Basically, if you want to parallel 2 generators, we know that voltage, base sequence, and frequency has to match with each other. So we use synchronous scope, which is also part of auxiliary engine control system, so that the incoming generator can be taken on load or can be made to run parallel with the already running generator. Well, so other than that, we are seeing the power factor meter. Well, the indication of whether generator is running or not, the circuit breaker is closed or not. So yeah, the ammeter, the governor, the circuit breaker of the engine to start, and then the emergency stop. So basically, that is one control panel, one area from where you can control the auxiliary engine. Secondly, this is one more area, the second area that is present in my engine control room to control the auxiliary engine. This is actually the power management system from where I can prioritize my generator. Like suppose if one generator is running and there is going to be a more power demand, so I can prioritize which generator next to take on load, maybe second, third or fourth generator or what. If I'm at high seas, I don't want my generators, I'll be using shaft generators, turbine generators to meet my power demand. It is based on the manufacturer and the ship owner requirement. And moreover, the power that my generators can produce is around 20,000 kilowatt. Okay, anyways, so that is the second area through where you can control your auxiliary engine. Now this is one more third area from where I can monitor the alarms and trips, as well as also control by setting the alarm value of the auxiliary engine. So this is the third area, that is the CAMS, control and alarm monitoring system. So I can see the alarms are okay or abnormal, like jacket cooling water, high temperature alarm, lube oil low pressure alarm, and their trips like engine overspeed trip, then fuel oil inlet high temperature alarm, fuel oil leakage alarm, the engine sump tank level alarm, So, and other than that, this just in CAMS, I can also use this as an PMS repeater unit. Wherever I see in PMS, the second in place of auxiliary engine control system, I can use this CAMS also to view, So basically, the CAMS can also be used as a repeater unit of PMS. Alright, whatever. So what you see here is the generator engine that is present on my ship. The manufacturer of the generator engine is STX in collaboration with the MAN. This is a 4-stroke engine with 8-cylinder. Yeah. So this is a very big engine because the generator is of high voltage, which produces up to 6,600 volt. That is 6.6 kV. That is why the engine that is driving the alternator is so big. So on the left end is the alternator, yeah. So, but now we are not focusing much on the alternator. We'll just focus on the engine and its control system, okay. So far we understand that there are three places from where we can actually control the auxiliary engine from the ECR. One is the control panel, the CAMs, the PMS. Sorry. And the fourth and final one is locally. Those are remotely controllable, and this is from the engine side itself. We can control the engine. So this engine control system is present in the engine side itself. So on my ship, in my engine, I'm having a control panel, HMI panel, that is the human machine interface on the generator engine side itself. So in this side itself, I can look for the parameters, I can change the values of the parameters, I can set the value when to trigger the alarm, when to trip the engine, you know. So CoC is the manufacturer of this HMI that is present on my ship. So basically this CoC will communicate with the control module that is present inside this particular control panel, which obviously communicates with the other three remote control areas that is present in the engine control room via the digital signals which carries the binary codes 0 and 1. And other than that, the control module that is present inside this engine control system also receives analog signals from the sensors, from the transmitters that is used to monitor the safety, the parameters that we all get. So they use the analog signal. So basically what I want to get to know you is that this particular control system works with two signals. One is with the digital signal, the other with the analog signal. Analog signal uses the sine wave, the digital signal uses the binary codes to communicate with each other. I mean, the networking system, the communication, everything goes with the digital signal. All right, let me show you inside, maybe you'll get a better idea. So yeah, on my left I see the HMI communicating with the control module that is present over there. Yeah, this is the control module, and this particular control module is of 24-volt power supply. And below this control module, we've got around 10 fuses, the relays, the terminal connections. So yeah, these are the relays. So these relays are, for generating, triggering the alarms, for starting the engine. There is a start relay, always 4x in most of the engines. That is a start relay. Anyway, so the fuses that we saw are responsible for display module, all miss detectors, with the speed governor, and so on. So basically inside this heart of the control system, this is what you'll be finding, and how it is communicating with the other three, or how the four control areas of the engine are communicating with each other. All right, now let's get into the alarm and trip section. So this is the all miss detector alarm. Initially it gives the alarm, then it will trip the engine, So yeah, the second one which we see here is the fuel oil inlet temperature alarm. So basically that is a temperature transmitter, and OMD is an oil miss detector. And here we see the pressure transmitters. So these are the pressure transmitters which communicate with the control module using the analog signal, which I told you, with the sine wave, So as we are seeing over here, there is also a test procedure for this. Either you can test this and simulate the alarms using, like for temperature, maybe a temperature calibrator, for pressure transmitter, maybe using a pressure calibrator. If not, you see a valve over there. Yeah, this one you have to close, stop the flow, then release the pressure. Yeah, that's how. So then you can activate the alarm. So this is how you activate an alarm from the pressure transmitters. And other than that, you have a float switch for fuel oil leak of alarm. Yeah, so this is the place you remove and lift the float. So this is one responsible for that. And this is the governor, which is used to control the speed of the engine, which has a lever at the back of that, where if you raise the lever, you will activate the overspeed alarm. And this is the pickup sensor, where you got to have a maintenance of the engine. And this is the jacket cooling water temperature transmitter, which also triggers an alarm and trip. In fact, to know how to simulate the alarms and trips, I will put a link on my description. Please check it out.